Number of solutions of an equation. We're going to take these three equations that we have in front of us here, and we're going to solve each one of them. And two of them are special cases. And you'll see what happens as to why we consider them special case equations. Looking at that first one, you know to look for the distributive property first. So that becomes 2x plus 12. And then I may choose to subtract 2x from both sides to gather my x's on one side and then move my numbers to the right. But then all of a sudden, I end up with 4 equals 12. That is absolutely false. So 4 does not equal 12, ever. So when you come up with a false equation like that, we consider this to be an equation that does not have a solution. So this is the type of no solution equation. Let's take a look at the one right next to it. Start with the distributive property. 4x minus 12 equals 6x plus 8. I'm going to choose to subtract 4x from both sides. So far we look pretty good. Negative 12 equals 2x plus 8. And now I'm going to move the numbers, or the constants, to the right. I get negative 20 equals 2x. If I divide by 2, I get x equals negative 10. Okay? So that's the case that we deal with the most. There is one answer that is correct. One answer is true. So this is just one solution. These are the types, again, like I said, that we deal with the most. Over here in this third equation, I'm going to do the same thing. 3x minus 6 equals 3x minus 6. And just kind of say that to yourself. 3x minus 6 equals 3x minus 6. Okay, maybe if you've got sort of a little warning going on in your head, that's probably a good thing. But if not, all right, let's start moving some variables. And 3x minus 3x. And then over here on the right-hand side, 3x minus 3x. And we're left with negative 6 equals negative 6. We don't have a variable here, but does negative 6 equal negative 6? This is true every time. So this is the situation where we have infinite solutions. So we could say that the infinite solutions and the no solutions are the two new types of equations that we need to talk about. So it says try plugging in some values into each equation. So in the first one, I might pick x equals 1, just because it's nice and simple. And I look back to my original equation, and I put a 1 in where I see the x. So I'd say 2 times 1 plus 4 equals 2 times 1 plus 6. So on the left-hand side, I'd say 2 plus 4 equals 2 times, let's do what's inside the parentheses here, 7. Does 6 equal 14? Nope. So that confirms that this is false. So then let's look up at the second one. Now our solution was x equals negative 10. That's the only one that's going to work or check. So if I put negative 10 into my original equation, wherever I see an x, okay, just did that substitution. Now let's think of order of operations. Whoops, that's a positive there. Equals, and then I might multiply. So what is 4 times negative 13? That's negative 52. And negative 60 plus 8, that's another negative 52. So that's true. That checks. Over here in this last one, if there are infinite solutions or many solutions, I could pick anything I want in here and it's going to come out to be true. So let's try x equals 0. Again, a nice easy number to work with. And when I substitute that into the equation, 3 times 0 minus 2 equals 3 times 0 minus 6. So order of operations, take care of the parentheses. On the right-hand side, I might do this multiplication, which is 0 minus 6. So I get negative 6 equals negative 6. That is true all the time. Okay? You could test x equals 1 in there as well, and that would work. Any number that you could imagine, when you plug that into the original equation, it's going to be true. This is negative 1. And we end up with 3 minus 6. So we have negative 3 equals negative 3. Again, that's true. Okay? So let's go over to the next page and let's deal with some vocabulary. So the null set, what does that mean? Okay? The null set means no solution. That was our first example on the front page. We know when the equation comes out to be false. It's also called the empty set. So lots of terms that mean the same thing. Null set, no solution, false, empty set. All kinds of synonyms there. We have some symbols that we can use to indicate no solution, null set, or empty set. One of the symbols to indicate that are these two curly little brackets with nothing inside it. Okay. Another symbol that we could use to indicate no solution is the 0 with the slash through it. Okay. So I just kind of took care of the symbols for that. Now the identity, that is our infinite solutions. Okay, our third example on the front. Infinite solutions, true for every number. And the symbol for that is the infinity symbol, sort of that sideways 8. Okay. So let's put this in a little chart here. Okay, so the words for the null set that I will probably use most often is no solution. An algebra representation of that, we end up with something that's false. The left side does not equal the right side. One solution, okay, there's really no other terms for that other than one solution. You get something, you get a variable equal to some number. And then the identity is infinite solutions. That's what I'll use most often, okay, infinite solutions. And what does that look like? Where the right side equals the left side. The examples, okay, I'm just going to write C, the front page of these notes, the front page of 1.6 notes, because those are 3 examples. And then sort of what are some clues to look for? So you could get down to 3 equals 4, that algebra representation. So clues, where the left side does not equal the right side of the equation. Okay, that's a clue to indicate no solution. What about to indicate one solution, where x is by itself equal to a number, any number. Like I said, that's the one that we're most familiar with. And then clues to look for on the last example, on the identity for the infinite solutions. The left side is exactly the same as the right side. All right, we're going to spend some time in class on these examples, and then we're going to kind of mix them up. So you're just going to be given an equation, you're going to have to solve it, and then you're going to have to determine, okay, is it just one of these normal ones where we get one solution, or is it one of these new ones, okay, these special cases where there's no solution or there's infinitely many solutions?